So our next speaker is Ankita Raturi. Ankita is a PhD student in informatics. How long have you been here, Ankita?
5 years.
5 years. So she's an experienced graduate student, and so she can tell you a lot of different things. But the interesting thing about Ankita, Ankita has been in lots of different places. She's very well traveled. She was born, she grew up in Kenya. Then she went to, let me see if I can remember this, she told me this. She went to Papua New Guinea, and then
Australia,
and she did her undergraduate, while she did her undergraduate, she was in 3 different countries in 3 different years.
Yes.
Right, so are those the 3 countries, or no?
So no, undergrad was, my first year was in Melbourne, my second year was in Fiji, and my third year was in Vancouver.
Oh my God.
So you can see, and then she decided to come here to do her PhD, and she works on a very interesting topic, and she'll tell you how she found the topic, how she found the advisor, and how she ended up working on very interesting work on sustainability and agriculture-related topics, actually. So, I'd like to hear.
I think I'll go without
You go
that.
without that?
Otherwise I feel like I'm shouting. Can you hear me?
Yeah.
Cool, perfect.
If you can't, I have this here.
Well, hi. After that very serious introduction, I feel like I should follow it up with something substantial. So my name is Ankita. I am in the informatics department, but I am also a software engineering major. And my work is actually in the intersection of both software engineering and sustainability is very broad and very sort of nebulous. So let's be a bit more specific. I work specifically on environmental sustainability with respect to agricultural systems. So my work involves looking at ways in which we can build modeling tools for doing the environmental assessment, not necessarily of large-scale farms, but of the new up-and-coming small to medium-scale alternative farms. And so what it is I'm riffing off of work in life cycle assessment that comes from environmental science. And so in environmental science, you have these beautiful modeling tools. They're very intense. It's like MATLAB, but instead of doing code, you're building models of systems in the world. And you're doing this specifically so that you can see what the environmental footprint of the system in the world is with respect to all these different parameters. Okay, so these tools exist. They're fabulous. They're really good if you're analyzing a very large, heavily industrial monoculture style farm. Where they break down is when you start trying to model things that are not sort of commonly done. And so you have a lot of urban farms that are coming up. You have a lot of organic farms. And now we're starting to ask questions about, how is an organic farm actually better for the environment than the large corn farm in Iowa? And so I would like to build tools to help us actually do some of these comparative assessments. And so the sort of like 3 primary challenges that I'm going to encounter from a software engineering perspective are sort of like, I joke that they're sort of like the Brooks style challenges that we see when we're trying to do software modeling. We're trying to find ways to capture complexity because agricultural systems are complex. There's lots of resources flowing through it. There are lots of interconnected systems. It's highly heterogeneous. There's a lot of stuff going on. It's not really something that's very static. And so in that sense, there's also a lot of change. So you have to now find ways to capture change. If I am a farmer and I've built this elaborate model of my farm, I decide, okay, you know what, I'm going to change it from this irrigation system to a drip irrigation system because I hear it's good for my water footprint. You do that, but now what you usually have to do is redo the entire environmental assessment. I would like to find ways in which we can actually do things like build version control for environmental assessment models. And so in that way, I'm trying to find ways in which I can take the skills that I've learned over the years in software engineering and apply them to something that is sort of, for me, a very interesting topic and something that I feel is important given the fact that we are having lots of conversations about food security and environmental sustainability and all of the other big things that we're discussing. And so I realize now I'm about to start rambling about all of the different things that I find interesting about this, but instead of doing that, I'll cut it short with respect to what I actually do research-wise. If you are interested in learning more about this, please come by and chat with me. Over the summer, I'm actually going to be getting to do something that most software engineers don't. I'm going to get to do some farm visits. So I'm actually going to conduct a series of field studies, go talk to farmers about, okay, given my vague understanding of how I think you're creating these models and how I think you're doing these environmental assessments, what are you doing? Let me not build for you, let me build with you and actually be part of the design process. And so I'm really excited. I'll like actually get to be outdoors in summer instead of like in a lab coding, even though that's fun. But you know, that'll come in the fall. But yeah, so that's sort of the long and short of what I'm doing and what I'm up to these days. Cool.
You didn't talk about how you got to grad
Kita's
school.
my student.
Sorry?
You didn't talk about how you got to grad school.
How I got to grad school? Well, somewhere between sort of like figuring out where my feet were that day, I found myself in Fiji and I was like, well, you know what, grad school seems like the place to go to. Actually, the thing that I originally wanted to study was open source economics. And so I actually cold emailed a set of professors with this like somewhat similar to the talk I'm giving right now, like very excited. I really like these things about the world and how on earth do I get involved, right? I've been like doing side interest work on open source projects, but I don't really know how to formalize this and I really want to spend the rest of my life doing this. Please tell me how. So my email sort of just got sent around this like weird long chain and ended up in Bill Tomlinson's inbox. Bill Tomlinson is a professor in the informatics department here. And he bid. He said, sure, let's see what you can do. And so like I did some like Ruby code for him over 2 weeks while I was in Fiji because he was like, I don't actually know where your university is. So given that I have no idea what kind of stuff you've been doing in your undergrad, let's just build something together and see how it goes. So that was fun. That was a nice way of also sort of like getting to have a sense for what it was like working with a professor at an R1 institution in the United States. And so I was like, sure, that sounds like fun. He seemed to enjoy it. I liked it. So I took a plane. But yeah, so I guess that's how I ended up with Bill.
Interesting story, I told you that, right?
And now we're doing agricultural systems. I promise you there's a thread, if you ever want to hear that little part.
I think it's a very interesting area nowadays called food, water, energy nexus, right?
Mm-hmm.
We're looking at, you know, you're using up a lot of resources with water and energy, and
Right.
there's food, and there's a lot of wastage of food,
Exactly.
right? So
Yeah.
can I produce locally, consume locally? That's, I guess, the...
Can I track the resources flowing between these systems? Can I find bugs in farms that aren't insects, but like bugs in the sense that we know them as software engineers, right? Bottlenecks, things that are going wrong. Sorry. I'm done. Cool. Thank you.